Hello, this is Mr. Stansbury. I'm going to go through one problem here from the 5C assignment. Okay, it's kind of a shorter one, so we're just going to work all the way through number 2 to make sure you've got stuff figured out. Okay, number 2, 15 students were weighed and their pulse rates were measured. Here's all the data. Draw a scatter diagram, calculate R, and then all the rest of this stuff. So let's start with the first thing, draw a scatter diagram. First one, I'm always going to have X. The second one, listed, I'm always going to have Y. So this is weight in kilograms. And then this is pulse rate. Pulse rate, and that is BPM, beats per minute, right? So what you want to do is you want to look at really find your highest value in here, which looks like 64. And then really in this here, you also want to find your lowest value since there's not very many low values. It looks like the lowest is what, 28? Okay, so this goes from 28 to 64, and then we want to do the same thing with the Y, find the highest, and in this case probably the lowest. So 87 looks like the highest. And then what do we got? A 54, and 53 is the lowest on that one as well. So what we might want to do here is do our little, before we make our scale, make our little zigzag thing here to show that this thing is broken, that we're not starting right at 0. Okay, so we know on the top one we want to go from 28 to 64. So let's maybe go, we could start this at, I don't know, 20. We could do 25, I guess. So I'll do, say, 25 here, and we want to go up to 60. So we can do 25, and then 30, 35, 40, 45, 50, 55, 60, 65, 70. That would get us in there. So let's do that. So every 2 of those will be 5 more. So 30, 35, 40, 45, 50, so forth and so on, right? Oops, 55, 65, and 70. That's a good way to make sure that we get some data over here in this second half, okay? And then with this, we go from 53 to 87. So maybe we start this at, let's see, say maybe 50. And then we got to go up to 80, so that's only a difference of 30. So maybe we can do the same thing here. Go every 5, so 55, 60, 65, 70. We got to get up to 87, 75, 80, 85, 90, 95 up here. Okay, so that will get us some data in the top half and the right half as well. Okay, so now we're just going to simply want to graph the data here. So we got 46 and 65. So 46, and again, I know this is kind of a weird one, so you just get close-ish, 46 and 65. So we'd go with about right there. And then we'll also graph all the rest of these pieces of data. Okay, so here's what we get, which looks like a fairly linear graph, linear set of points here. Okay, calculate R. So remember, if we're going to calculate R, we're going to have to put that into our graphing calculator. So you got to do stats, and you're going to edit, and we're going to edit our list. So first thing we got to do before we edit our list is, I always like to clear the data out, so in case I end up with not enough pieces of data to overwrite the existing stuff. So clear it out, and then we're just going to enter all of these into list 1 and all of the Y's here into list 2. Okay, so we got all of our data entered in here. So we do stat, calculate, linear regression, push enter, make sure that list 1 is for X list, list 2 is for Y list, and there's nothing listed in frequency list. Down to calculate, we push enter, and here's the equation linear equation that would fit for that, and then here's our R value, 0.929. Okay, Next, describe the relationship between weight and pulse rate. So obviously as the weight goes up, the pulse rate goes up as well. Okay, calculate the mean point, the X and the Y. Okay, so we already have the data in here, so now we can actually find our mean point in here. Okay, so what we want to do is we want to go into stat. You're going to go over to calculate, and now we're going to calculate two variable statistics because this is weight and this is pulse rate. These are two different variables, so we're going to calculate two variable stats. Push enter, and then same thing, X list is list 1, the Y list is list 2, and there's nothing in the frequency list. And we go down to calculate, push enter, and it gives us this whole mess of data. Here's the X with the bar is our mean for the X, and the Y with the bar is the mean for the Y. So it's 45 and 64.6. That is the mean point, okay? Locate the mean point on the scatter diagram and use it to draw in drawing a line of best fit. Now this is big. If you're on the IB test, if you ever are asked to draw a line of best fit, you always have to include the mean point, and we just found the mean point, so you got to put 45 and 64.6. So that's basically 45 and almost 60, so I'd put it right there. That's our mean point. And if you're doing this on your test, and this, it's easy for us to show what the mean point is because it's red. I would even draw a point here. It says mean point. And even maybe give the data 45 and 64.6. 45, 64.6. Then they know that you know that that's the mean point, okay? And then use it drawing the line of best fit. So to draw this line of best fit, what I'm going to look at here, what's probably going to be helpful, stat, I'm going to do this, calculate. I'm going to go back to our linear regression data, and it gives us our, once we get down here, sorry, it gives us our equation eventually. And then the B right here, that's the y-intercept. So you know what I would do? I'm going to use this y-intercept, 31.4. So what I'm going to do is I'm going to do, we don't really have a 31.4, so it's 50. Okay, so the 31.4 is going to be way down here. So that's not going to be super helpful. So we're just going to have to sketch one in here. Okay, so I would maybe go with, something, basically it's got to go, super important, it has to go through the mean point, and you want to draw it so it has the same number of dots above and below, and that looks pretty close. There's a few more below here, so you could possibly even tilt this up a little steeper, more like, say here instead, and that might be a little bit more accurate, okay? But that's your use it to draw a line of best fit, and that is going to be close-ish. It's not an exact science, at least for as far as what we need to worry about, but it does have to include the mean point. Okay, use this to estimate the pulse rate of a 50 kilogram student. Comment on the reliability of your estimate. So 50 would tell us it's about right here, which is, say, looks like about, say, it's just under 70, so we'd say about 69 beats per minute, okay? And I would say comment on the reliability of our estimate. That is within our data range, so it should be fairly reliable. That should be pretty close. Okay, if it was outside the data range, then that would be an extrapolation instead of an interpolation, and the extrapolation is less likely to be accurate. Okay? All right, that's all I have here for the 5C. So if you have any questions on this or any other problems, please feel free to ask. Thanks.